Hi everyone and welcome back. Today we're going to look more at quadratics, and today we're going to look at how do we find the vertex but algebraically. That means from the equation. A couple of reminders: we're going to have a test on Wednesday of next week. Okay, I will be here Thursday after school in case you need anything, and again in case you decided to do that um, optional packet because you were not pleased with how you did on the linear equations exam. Okay, that will be due on Thursday as well. So tomorrow I'm there after school if you want to go over a few questions, but you should have most of it completed by then. So far, just to remind you what we've done, we've looked at properties of quadratics, we've looked at graphing a quadratic, we've looked at how to determine the axis of symmetry. Okay, so the axis of symmetry, remember, it's a formula that you are given, and it's x equals negative b over 2a, where you have the quadratic equation ax squared plus bx plus c. So the a is the number in front of the x squared, the b is the number including the sign in front of the x. And what do we always need to remember? We always need to remember the equal to sign. It's an equation, so it should always be x equals some number. We're going to use this fact with the axis of symmetry to help us figure out the vertex algebraically. Okay. So far we've learned that every quadratic equation has a vertex. Other ways to say vertex, you should be thinking to yourself right now, oh, it could be the turning point, or it could be the maximum or minimum point. So notice that I'm saying point here. So that means that if it's a point, then it's going to be a coordinate point, x comma y. And that's how we're always going to write our vertex. So steps to find the vertex. The first step is to determine the axis of symmetry. So we're going to use that formula from our formula page, x equals negative b over 2a. Then we're going to use that x value that we get and the function that we're given to determine the corresponding y value. So what I'm saying here is we're going to plug in x to find y. And the x that we're plugging in is the one from the axis of symmetry. And then we're going to write our answer, our final step, as a coordinate pair, meaning x comma y. So 3 steps. So let's try this. Determine the coordinates for the vertex of f of x equals, that's another way of saying y equals, x squared plus 6x plus 4. So when looking at this, I say, okay, my a is 1, my b is 6, and my c is 4. Notice this is also your y-intercept, that 4. So my first step is to determine the equation for the axis of symmetry. So I'm going to say x equals negative b, so negative 6 over 2a, so 2 times 1. So x for us is going to equal negative 6 over 2, which gives me negative 3. Now what I'm going to do is I'm going to take that value, that negative 3, and I'm going to plug it into my function. Y equals x squared plus 6x plus 4. So I'm going to say, okay, y equals negative 3 squared plus 6 times negative 3 plus 4. And on your calculator, if you do this using the parentheses that we have here, you should get negative 5. So then our vertex as a coordinate pair would be negative 3, negative 5. So we use the axis of symmetry to determine the x value, and then we took that x value, plugged it into our formula or our function to get the y value. So we're going to follow these same 3 steps below in a second example. So the second example says determine the coordinates of the turning point. Remember, turning point is another word for vertex, of y equals 3x squared plus 6x plus 2. So my first step is going to be to find the equation of the axis of symmetry. So it's x equals, oh, we didn't identify a and b yet. So a here is 3, b is 6 again, and c, or our y-intercept, is 2. So I'm going to say negative b, which is negative 6, over 2 times a, 2 times 3. So I get x equals negative 1. Now that I have that value, I'm going to plug in x equals negative 1 into our original function. So I have y equals 3 times negative 1 squared plus 6 times negative 1 plus 2. So I get y equals, again, in your calculator, you can do this in one step as long as you use the parentheses. If you do this in your calculator, you should, I believe, get -1. So then the turning point here would be -1, -1. Now these are things you can always check with your graph, but it's important to be able to do things with the graph and also without the graph, with just the equation. So for today, your classwork, it's a little bit shorter than normal because I want to make sure that you really understand everything. So your classwork, I'd ask you to complete it, and once you're finished with it, you can go back and make sure you're done with any other classworks that we've had. If you need to, you should re-watch some of the videos to make sure that you feel comfortable with things like the axis of symmetry, the y-intercept, and turning points. Okay, so at this point you should be able to answer your learning goal number 4, how do we determine the coordinates of the vertex? And you should be able to, on your learning goal sheet, say, okay, first determine the axis of symmetry. Second, plug that x value into your function or equation to get y, and then write your answer as a pair, coordinate pair. Okay, so at this point we have completed 4 learning goals. So what I'd like to do now is I'm going to show you some of the answers. So when you are done with the classwork, you can check your answers here. This will also be posted on my big campus for you to watch. So here are the answers. So 1, you should have gotten the vertex to be -2, -12. For the other question in number 1, you should have gotten 6, 7. For question 2, you should have gotten the axis of symmetry to be -6. Plugging that in, you should have gotten 24, giving you your vertex of -6, 24. So follow those 3 steps. What's the vertex of the following graph? Since you have the graph, just look at the turning point. Okay, and the coordinates of that are 4, 2. Question number 4 was a review of lines, x and y intercepts. This is a big one. So to get the x-intercept, plug in y equals 0 and solve for x. To get the y-intercept, plug in x equals 0, solve for y. So there's 2 answers here. You're clearly marking them by plugging in y equals 0 or x equals 0 to get the x-intercept and the y-intercept. Some of you might have tried to get the y-intercept by putting this equation in y equals form first. That would have worked as well. Okay. What I ask that you do once you finish reviewing all of this, completing all your questions, is that you make the flashcards to help you study. Okay, so I told you exactly what I think would be helpful on the front and on the back of each flashcard. I look forward to seeing you tomorrow. If you have any questions, you can always email me.